The cosmos is a place of immense power and intricate connections, where invisible forces shape the fate of our world every single day. Forces that begin thousands of miles away can shape the world right outside your window, influencing the air you breathe and the weather you experience. As we approach the end of 2025, meteorological models point to a rare convergence of events, the kind that only happens once in a generation. These are not local weather patterns, but giant atmospheric engines synchronizing to unleash a significant winter storm across Eurasia, with the potential to disrupt millions of lives. This is a story of physics, of air, water, and how our planet's climate systems can align to create something epic, something that will be remembered for years to come. 3 massive climate phenomena are predicted to align in December 2025, each one powerful on its own, but together, they could reshape the season. Each can change our weather, but together they can create extreme conditions, blizzards, freezing temperatures, and storms that test our resilience. Scientists see the warning signs, pieces of a grand puzzle falling into place from the Pacific Ocean to the North Pole, hinting at a winter unlike any other. This isn't a nightly news forecast, it's a long-range risk analysis, a glimpse into the future shaped by data, science, and experience. Climate scientists see large-scale conditions developing, making a major event highly probable, and they are working tirelessly to understand what's coming. Our journey will explore these 3 forces, each a key to unlocking the mystery of the coming winter. A Pacific Ocean temperature shift, which can send ripples through the atmosphere and alter global weather patterns. A spinning vortex of cold air, poised to descend from the Arctic and bring frigid temperatures to vast regions. And a pressure system over the Atlantic, steering storms, and influencing the path of winter weather across continents. Understanding these elements is key to grasping the significant weather that may be heading our way, and to preparing for what lies ahead. It's a reminder that we live on a dynamic, interconnected planet, where every action and reaction in the atmosphere can have far-reaching consequences for us all. Our story begins in the vast Pacific Ocean, a place so immense it covers more than a third of our planet's surface. This is where some of the most powerful forces shaping our weather are born, often unnoticed by those living thousands of miles away. Here, La Niña is expected to be active, quietly influencing the world's climate from beneath the waves and high above in the atmosphere. La Niña is a cooling of the ocean's surface in the central and eastern tropical Pacific, stretching across an area larger than a continent. This drop in temperature may seem small, but its effects are anything but. This cooling alters atmospheric circulation, sending ripples, known as teleconnections, across the globe. These invisible threads link distant regions, connecting weather patterns in ways that can be surprising. La Niña can affect everything from India's monsoon rains, which millions depend on, to the frequency and strength of Atlantic hurricanes that threaten coastlines each year. For Eurasia, La Niña acts as the first domino, priming the atmosphere for cold outbreaks in the northern hemisphere. It sets the stage for winter's arrival, sometimes making it harsher and more unpredictable. It changes the path of the jet stream, making it more wavy and unstable, allowing cold polar air to dip much further south than usual, reaching places unaccustomed to such chills. So, while few in Europe or Asia think about the distant Pacific, the climate system does, linking their winter weather to events unfolding far away. La Niña doesn't cause the storm alone, but it creates an environment where other factors, like Arctic air and local weather systems, become more effective, amplifying their impact. It's the first critical piece of the puzzle, setting the stage for the atmospheric drama that will unfold in December 2025, as different forces come together in a complex dance. The process starts here, with a subtle but powerful nudge to the global system, reminding us that even the quietest changes in the Pacific can echo around the world. Now, let's travel to the stratosphere above the North Pole, home to the polar vortex, a massive swirl of frigid air. When strong, the vortex locks cold air over the Arctic, resulting in milder winters elsewhere. But when it weakens, the vortex wobbles, releasing Arctic air southward. This is the second key ingredient for our potential storm. A weakening vortex can displace huge masses of cold air into Eurasia and North America. This is how deep freezes and prolonged cold spells begin. The process takes time. Signals from the stratosphere take days to reach the surface. Scientists can spot these signs and forecast cold outbreaks weeks in advance. For December 2025, models indicate a high probability of a weakening vortex, setting the stage for a major polar air displacement. The cold isn't new, it's simply unleashed from its polar prison. This is the mechanism that delivers the bone-chilling cold. The final piece is over the Atlantic, the North Atlantic Oscillation, or NAO. The NAO is a seesaw of air pressure between Iceland and the Azores, controlling Europe's winter weather. In its positive phase, strong westerly winds bring mild, moist air to Europe. But in the negative phase, a blocking high near Greenland stops these winds, closing the door to Atlantic warmth. Instead, cold, dry Siberian air flows westward, creating Europe's most severe cold spells. The negative NAO is the third crucial ingredient for our perfect storm. It creates an atmospheric highway for freezing air to surge into Europe. The weakening polar vortex helps push this cold air south, while the negative NAO opens the pathway. December 2025's 2025. Models predict a strong negative NAO, setting ideal conditions for a westward flood of Arctic air. This is how Europe gets its most memorable winters. The stage is set for a dramatic shift. Let's put the pieces together. La Niña primes the global system, making it more volatile and ready for cold outbreaks. The weakening polar vortex unleashes Arctic air, disrupting the jet stream. This disruption helps flip the NAO into its negative phase. The negative NAO sets up a blocking high over Greenland, stopping Atlantic warmth. With the west blocked, frigid air pours into Eurasia. It's a 1-2-3 punch. La Niña, polar vortex, negative NAO. Each amplifies the others, creating a feedback loop for extreme weather. The result, not just cold, but a prolonged severe winter event across a vast area. This rare alignment makes December 2025 so significant. Zooming in on the Caucasus, this mountainous region is uniquely vulnerable. The negative NAO steers moist Mediterranean air north, colliding with cold air from the northeast. The result, heavy, rapid snowfall that can bury landscapes. The danger isn't just snow, but the chain reaction that follows. Massive avalanches and geo-hazards. Heavy, wet snow destabilizes steep slopes, increasing avalanche risk. As temperatures fluctuate or rain falls on deep snow, the risk of floods and mudslides rises. Meltwater can't soak into frozen ground, triggering sudden disasters. Rivers can swell, and hillsides can give way, threatening communities below. The initial storm is just the beginning. Hazards can persist for weeks. For the Caucasus, preparedness means monitoring both the sky and the mountains. The threat is multifaceted and serious. In western and central Russia, the threat shifts to prolonged blizzards and glaze ice. Frigid Siberian air brings storms that can last for days, isolating communities. The real danger is glaze ice, rain falling on frozen surfaces, instantly forming a thick, heavy coating. This ice can snap power lines, topple pylons, and collapse roofs. Massive power outages are possible just when heating is most needed. Roads become skating rinks, and repair work is dangerous. Trees and infrastructure are at risk from the weight of ice. For millions, the battle is not just against cold, but the crushing weight and isolation of a frozen world. December 2025 could bring a relentless test of endurance. As cold air moves into Western and Central Europe, the threat becomes extreme variability. Instead of a constant freeze, Europe faces sudden severe cold snaps, flash freezes. Temperatures can plunge by 15 or 20 degrees overnight, turning wet roads to black ice. This shock effect strains energy grids as heating demand spikes. Infrastructure is at risk. Pipes can freeze and burst, causing flooding. The danger is being caught off guard by rapid swings between mild and severe cold. Vulnerable populations are especially at risk during these sudden drops. The challenge is preparedness for volatility, not just cold. The shock and awe of sudden Arctic air defines the risk for Europe in December 2025. Adaptation is key to weathering these unpredictable events. It may seem odd to discuss a severe winter storm in an era of global warming, but this is the climate paradox. As the planet heats up, we might expect winters to become milder everywhere, but the reality is far more complex and surprising. Sometimes, warming can actually set the stage for more dramatic cold snaps. A warming Arctic can weaken the polar vortex, a swirling mass of cold air that usually stays near the pole. When this vortex is disrupted, it can spill frigid air much farther south than usual, bringing unexpected cold to places that have grown used to milder winters. The climate system is now more energetic and volatile, producing greater extremes. We see wild swings between unseasonable warmth and sudden intense cold, as well as storms that seem to defy expectations. As winters warm, society becomes less resilient to rare cold events. People and communities adapt to the new normal, often letting their guard down against the possibility of severe winter weather. Infrastructure and habits adapt to milder winters, leaving us vulnerable when severe cold returns. Pipes may freeze, power grids can fail, and daily routines are disrupted, sometimes with costly consequences. Climate models can identify the risk of a major event, but not the exact details. Scientists can see the warning signs, but the precise timing and location remain elusive. We know the three main ingredients: La Niña, a weak polar vortex, and a negative NAO, are likely to align. These patterns set the stage for potential winter extremes, but we can't predict which city will be hit or when. The exact path of a storm, or which region will feel the brunt of the cold, remains uncertain until the last moment. This is a probabilistic forecast, not a guarantee. It's about understanding risk, not certainty, and preparing for a range of possible outcomes. The message: be aware and prepared, not panicked. Taking simple steps now can make a big difference if severe weather does arrive. As December 2025 approaches, forecasts will sharpen. Meteorologists will have more data, and predictions will become more precise. For now, we see only the outlines of a potential storm and have the chance to prepare. This window of uncertainty is our opportunity to act wisely. The power of our planet's climate is both magnificent and humbling, reminding us that even in a warming world, winter's surprises are never far away.